Welcome back, class. Thanks for tuning in. Again, hope everyone's well and healthy, and that you're taking care of yourselves, taking care of each other. We're going to jump right in and talk about part 3 of this week. So let's jump right in here. What you're looking at here in front of you is the plan for today. This is part 3 of week 6. I might have incorrectly stated that earlier, but we're still doing scientific notation. We're going to do this in the next video as well, talking about kind of the importance of what this is used for. All right. So what we're doing here is we're doing scientific notation, proper scientific notation, where you can change a large number to a decimal form, if you will, if that makes any sense. So let's kind of jump in here and kind of look at what we're doing. All right. So I know this is a little small. Kind of read it as you're going through it, but if you can see it on the screen, it's talking about a photocopy paper has reams. That's the big packet of like printer paper, and there's 500 sheets in that ream. That's what they call it. And the thickness of this pack happens to be 41 millimeters. What is the thickness of just one sheet of this paper? So you have 500 sheets. It's 41 millimeters each. So we want the thickness per sheet. Okay, so the trick is you're going to take 41, and this is really the stuff we're going to be looking into like next time, which is going to hopefully make a little more sense as we go into the next video for week 7. But we have 41 millimeters per ream, and we're going to divide this by the 500 sheets that I have. And what this is going to give us is going to give us a very small number, and this is the millimeters per sheet. Now, how that works is the word per means a fraction bar. So when we actually divide by the sheets here, that's per sheet, that's the division bar. So that's what we're going to be looking at. So let's just type this in and let's go through it here. So what we have is 41. We're going to divide by 500, and I'm going to do this with my calculator, and I'll bring this up for you guys. So let's transit so you can see this. So on my calculator screen, I have 41, and we're going to divide by 500. And what we're getting is 0.82. So 0.082. And that's millimeters per sheet. So that's the thickness of one sheet at a time. And so in scientific notation, what this would be, let's clear that out. And let's get back into the program here. So what that would be if we change this to scientific notation, you move the decimal over 2 spots here, because I always want it behind the first number on the left side. So this is 8.2, and then we put it times 10. If it'll allow me to write that 0 for the 10. I find that's so weird that there's areas where it won't let me write. So 8.2 times 10, and now we moved it 2 spots, so we're going to put a 2, and now it's a negative. Now why that's a negative power is because this number that we started with originally was less than $1. It was 0.0, right? So it's less than 1. So the powers would be negative, because basically the negative power means you're moving the decimal to the right versus to the left. So that's what we're doing, and that's millimeters per sheet. So per sheet. All right. So there's your first one. Let's jump right into the next one here, and we'll kind of keep going. I think we have, 10 of them here that we need to do. All right, so we're looking at this one is the length of a bacterium. It is, 4 times 10 to the negative 5th inch, so it's very, very tiny. And we want to figure out what this is written in as a normal number. So it's already in proper scientific notation. So this is 4.0. That's how they always write those numbers, times 10 to the negative 5th. And we're going to move this. Now this number, this little negative power here, is telling me that we need to move this decimal. This original number was less than 1. So they moved the decimal at 1 point. So if I move this decimal 5 spots back, it'll give me the original number. That's how I know like negative power means it was less than 1 versus greater than 1. That's just like the overall rule that I always think of to remember like which way I need to move it. So I'm going to move it back 5 spots, and so this is what it's going to look like. Because if I started it here and it moved over 5 spots, 1, 2, so 1, 2, 3, 4, 5, yeah. So there you go. So there's your original number in its original form. So let's move on to number 3 here. So we have the diameter of the moon. So now we're getting to the practical stuff, like what this stuff is used for. It's used for very, very large numbers that you need to either write in different ways so that it can fit on a calculator, or we can just do some easy calculations with it. So what we have here is 3.475 times 10 to the 6 meters. Now it's in meters. And that's the diameter, right? So we want to write this as a normal number. So 3.475 times 10 to the 6. That means since this power here is a positive number, that means they're moving the actual decimal to the right side, because this original number was greater than 1, so I'm going to move it to the right. So if I move this decimal, 6 spots this way, I'm going to get 3475000. Now how I knew that is because the decimal's here, and I'm going to move it 6 spots. 1, 2, 3, 4, 5, 6, and that's where it's going to end up at. And so this would be my original number, and this would be in meters. So it's 3,475,000 meters. Okay, let's keep going here. We're going to go on to number 4 for my problems here. So we have a scientific notation number. It's got a negative power on it. It's got a negative 14. And we want to write this as a normal number. So the negative power means I'm moving it back to the left. So it's 7.085 times 10 to the negative 14. So I have to move this decimal 14 spots to the left. So this is what it's going to look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then the 7085. Now, again, why I counted 13 zeros is because the decimal is here originally, and I have to go back 1 and then 13 more. So, because this is the first one, and then if I count 13, that'll get me all the way to here. Sorry, I got an alarm going off. All right, so that is the trick for this one. How I knew how to move it, 14 spots. But again, it's 13 zeros, and then that first number where the 7 was. So that counts up to 14 total spots I moved it. All right, let's go to problem number 5 here. All right, sorry, this one got a little small. This is the mass of the moon, the mass, not the diameter. Mass is the actual the interior material, right? So it's quite a few kilograms. I don't even know what that number is. So that's hundreds, thousands, millions, billions, trillions, quadrillions, septillions. Wow, septillions maybe. So we have quite a few, 73, and there's a ton of zeros, and we want to write this in proper scientific notation. So currently the decimal is all the way in the back, right by the kilogram. And I'm going to move it all the way to the front, so it's right behind the first number on the left. So that's the 7. And I have a times 10. Now, obviously this number is greater than 1, so it'll have a positive power, and I just have to count back how many spots I move it. Now, the beauty of this is the commas will help me, because commas are every 3. So I can just count by 3s till I get to the very last. So so here we go. So this is 3, 6, 9, 12, 15, 18, 21, 22. So maybe it's the 22nd power. Let me just count that one more time. I want to confirm that is the 22nd power. 3, 6, 9, 12, 15, 18, 21, 22. Yeah, 22. And that's in kilograms. So it's proper scientific notation for that. That's really big. Moving on to the next one. Where are we on? Problem number 6 now, out of the 10 that we have. So the speed of sound in dry air. So dry air versus humid. What does impact sound? How far sound carries? It's like a foggy day. Sound doesn't travel too far because the actual density of the clouds actually hinder it. But this is a 68 degree Fahrenheit day. There's a conversion there to convert Celsius to Fahrenheit. The United States is one of the only few countries in the world that uses its own system for temperatures. And so the speed of sound is 1.236 times 10 to the third kilometers per hour. I find that funny that they gave me the conversion for the Celsius to Fahrenheit, but they didn't give me the kilometers per hour because we go by miles per hour. But write the speed of sound in normal as a normal number. So currently it's 1.236 times 10 to the third. So the third is a positive power, so I'm going to move that decimal to the right. So this would be 1236. The decimal would end up here because I moved it back 3 spots, because again, the positive power means that my original number was bigger than 1, and it definitely is. It's 1236, and then that's kilometers per hour. So quite fast, actually. All right, moving on. Let's go into the next problem here. What do we have? Problem number 7 out of 10. Okay, so, wow. Okay, so we have very small. This is the resting mass of an electron. So, very, very tiny. I'm not going to try to attempt to, say what that number would be. I'm just going to move my decimals. So, again, I want to write this in proper scientific notation. Now, it doesn't say proper, but I usually go by proper. So, I'm going to move this decimal where it's currently sitting all the way so it's behind that first number on the left side. So, that would be the 9. Okay? So, I'm moving that decimal all the way back there. Now, what I need to count is I need to count how many spots did I move it. Now, the beauty of this problem is that, that's why I picked it, it was that they gave you really nice spacing. Every 3, they kind of put a little space. So I'm just going to count. Now, obviously, I'm going to have it times 10, and I'm going to have a negative power because my original number is clearly less than 1. So it's going to have a negative power because I'm moving the decimal a certain direction. That's just how it works. So let's see. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 31 spots. Wow. 31, and that's kilograms. So quite small. Yeah, that's impressive. That's the actual real number for the resting mass of an electron. Moving on, let's go to number 8 now, our 8th problem out of 10. Okay, so we're back to writing this number as an original number. We have 3.56 times 10 to the 11th, and so if we write this as a normal number, so we have 356. Now I want to write this as a normal number. Now currently the decimal is here, and I need to move it 11 spots. Now it's a positive 11, so it's going to move back this way because my number needs to be bigger than 1. So I know kind of which way I need to move it because the way the power is positive or negative. So I'm going to move it back this way. So I've already moved it 2, so it's behind the 6, and I need to go what? Another 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that moved it a total of 11 spots. Alright, so there you go. The decimal will be all the way back there. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you go. Let's move on to our second to last problem here. The radius of the sun, this is in kilometers. We have 695,500 kilometers, and we want to write this in proper scientific notation. So currently the decimal is right after the 500. If they don't have it printed, it's in the back. So I'm going to move the decimal so it's behind the first number on the left side. So 395. All right. And now I can chop off zeros. If there's any zeros in the back, you can get rid of them. You technically don't need them. Times 10. But we still count how many spots I moved it. I still moved it 1, 2, 3, 4, 5. I moved it 5 spots. So I'm going to put a positive 5. Now, a reason why it was a positive 5, my original number was bigger than 1. So it kind of told me which way I was moving the decimal. So there it is, 6.955 times 10 to the 5th. And that would be the original number. And that's in kilometers. Okay, last problem out of our 10, and this will be the last one that I assigned by the Google form. Speed of light in a vacuum. So speed of light, again, not sound. So this is in what, meters per second. So that's what, 299,792,458 meters per second. So right now the decimal's in the back. So I'm going to move the decimal behind the first number on the left, so 2.99792,458. And again, there's no zeros for me to chop off like the last problem, so I'm just going to leave all those significant digits there. Times 10. This number, my original number was bigger than 1, so I'm just going to leave it as a positive power. And I'm going to move this decimal back, what, 1, 2, 3, 4, 5, 6, 7, 8. So I moved it back 8 spots. And there you go, and that's meters per second. Okay, so that's all the problems that we had form. Let me transition right here. But again, thanks for all those that are actively trying these activities each week. But again, distance second place to your own health. Take care of yourself right now. I know that we're kind of itching to get out and about. But again, safety has to be first priority for you and your family. But again, I'm hoping to see you guys real soon. And again, take care of each other and have a great day.